one more video. Let me just check some. Okay, yeah. This one video to go through the theory questions for this year's AQA A-level exam, target clear. I don't want to necessarily reinvent the wheel. Mr. Berard's done an excellent video on this in his live stream three days ago, but I thought I would just cover it just from the C# angle. Obviously, both of them are pretty much the same when it comes to the theory questions. But anyway, let's kick off and not waste any of your time and go through it, okay? So explain why the choice variable is converted to lowercase in the main subroutine. So this question is about the main, okay? So we'll look at this. What it's referring to, of course, is this choice variable here, okay? So that choice is basically saying that, you know, whether we're entering training mode or not training mode. And we've asked the user to enter a Y to play the training game. It's asking why is it converted to lowercase. So you'll see that it is converted to lowercase here. Okay, so by putting that dot to lower, it's going to make it a lowercase y. That means, well, two things really. We don't have to check for uppercase y or lowercase y. We can just check for lowercase y. It basically makes the input case insensitive, okay? So makes input case insensitive. So both uppercase y and lower case y may be accepted. Okay, something like that, okay? Be helpful if I actually put case correctly. Okay, explain the purpose of the training game variable in the program. So quickly again, the training game variable is actually a Boolean, which is false. This is passed through to the numbers allowed and to the play game and various other things. It basically means that the game is not acting in, or you know, may be acting in training mode or not in training mode, and the program can make future decisions based on this. So something like variable Boolean variable means that the program can operate in training or random mode. This variable is passed through various functions, so the program can make decisions based on it. Okay, let's just have a quick look at the marking scheme, which I've loaded up here just to double check. Determines whether the game is in training mode or random mode. In training mode, we could have said something like predefined numbers and targets are used, while in random mode, you know, we could have said that. Should we just add that to? We'll just cheat there. Okay, something like that. Okay, so this question is about the play game subroutine. It repeatedly calls the display state. Explain the purpose of this repeated call and how it contributes to the gameplay. Well, the display state is down here. So I'll just do a quick search for that. Display state. So it's called to give the user an update on the. So it's called to display to the user the game days, e.g. the current targets, the current numbers allowed, and the score. Okay, so again, hopefully we've made 2 points. Let's have a quick look at the marking scheme. The marking scheme may be a bit more, yeah, okay. Yeah, it helps the player track the progress and remaining resources. Okay, so next up, this question, let's get rid of that. This question is about the remove numbers used function. Now, I've said it in previous videos, if you're ever asked, you know, what function, what method is it that removes the numbers or something like that, don't say removed numbers used without putting these open and close brackets on the end. You lose a mark. Unfortunately, a couple of my students did that last year. I looked at the marking scheme and their papers. I thought I'd found them some extra marks when you know, when they'd actually clearly put the right method down for the answer. But if you don't put that open and close brackets on, they won't award you the mark. It's a quirk of the marking scheme. Not so sure I agree with it, but that's the way it is. So always remember to put your open and close brackets at the end. Okay. So identify the user input RPN. Identify what user input in RPN represents in this function. Well, the clue's in the name. It's the reverse Polish notation. We will bring that function up actually. Remove numbers used. Okay. I've got the right one, haven't I? User input in RPN. Okay, there it is. Yeah. Okay. So it uses this convert to RPN to get the user input and converts it into reverse Polish notation. So we'll say that this is the variable. Actually, I think it's a list. Yeah, it is. Sorry. This is this stores the user input string as a list in reverse Polish notation or postfix, something like that. I think we've said enough to get the mark. What does the marking scheme say? Yeah. Okay. Yeah. So we could add used for easy. I think we've done enough anyway. Easier validation. Explain the logic of the remove numbers from the numbers allowed. Explain the logic used to remove the numbers from the numbers allowed list. Well, we can just follow the code. It iterates through the list. So we can say a for loop is used to iterate through the list of reverse Polish notation if valid if a number matches it in the list matches the what's it called now, I'm looking at the right one here, aren't I? Remove numbers used. Yeah. Yeah. So thought this was fairly straightforward. I still think it is. Check if valid number. So yeah. So check if the item is within range of 1 of 0 to the max number, defaulted to 10. The target numbers. Sorry, the numbers allowed list. Okay, and if the numbers allowed contains the item, if numbers allowed contains the item, then it is removed. I think that kind of covers it. It's 2 marks, isn't it? Let's see what the mark scheme says. The function converts the user input to RPN, iterates through the expression list. Okay, for each valid number in the expression that matches the a number in the numbers allowed, then yeah. So I have been slightly rushed on that, actually rushed through it. So iterate through the list of RPN, check yeah, which contains numbers of a valid of a matched evaluation. Yeah, it's just trying to get the wording right. Okay, yeah. Okay, something like that anyway is what the numbers allowed does. You can just follow through it. Just make sure you say enough to get you 2 marks, but you can follow through that, for loop there, that's iterating through the list of user input in RPN. When it then matches it against the numbers allowed by checking if it's within the numbers allowed list, and removes it. Okay, simple as that. Okay, what is next? Oh, that's the marking scheme. Okay, right, next up. This question is about the function check if user input evaluation is a target, how it works to modify, and how it works to modify the player's score. What condition needs to be met to increase the player score? Well, what was it? Check if user input validate evaluation is a target. Check if user. Check if user. Oh, what have I done wrong? Check if user. Check. Not quite sure what I'm doing wrong here. Let's have a look at it again. In fact, why don't I just cut and paste it into that? Because with my eyesight, I can barely see it. Go to the top. There we go. There we go. All right. So, what condition needs to be met? So, the condition is that the user evaluation matches a target. When the so the targets, the list of targets are iterated through when a target matches the what was it called? When the target matches the user input evaluation, the score is increased by 2. Okay. Why is the target set to -1 after it has been evaluated successfully? -1 is used as a placeholder for a blank space in the targets, and this creates a gap. This creates a gap. The -1 is not matched. Is not matched in target position 0 to give the user some space. Okay. I'm not quite sure of my answer there. Again, I'm rushing. I don't want to waste too much of your time. It is the night before, after all. Okay, so we'll just have a quick look at the exam question. -1 is used as a blank space in the targets list. It does create a gap, and it's also there's a condition in there that says if it's -1 and it's in target 0, we don't end the game. So we could say actually the game is not ended until another number is in target 0. I think I pretty much got that right. Let's quickly look at the okay. So the previous one, the player's score increases when their evaluated expression matches one of the current targets. I think I've got that one. Setting the target to -1 marks it as a hit or used or blank space. The aim of the game is to turn the targets into -1 so that the player can survive longer as the loop ends when the non-1 are. I think I've said that. That's a bit more precise an answer. Mine is a bit rough, but I think I've kind of said the same thing. Okay, right. Okay, next question. Okay, this question is about the function check valid number. The function uses a regular expression. Make sure you've revised regular expressions. Okay, explain the purpose of using a regular expression in this function and how this regular expression works to validate the input. Okay, so what was it again? Check valid number. So check valid number. Okay, so there's the regular expression. Okay, regular expression is match. So that is the little caret there indicates that this must be at the start of this string, and it must be a 0 to 9. The plus means that there is more than one of them. Okay, so you can have 0 or 0, 0, 0 or 0, 9, 1 or whatever. And then the dollar means that there is no capacity to put a space. So if the user enters here for this item space 0, then that wouldn't be valid. If the user answers 0 space, then that wouldn't be valid, because these two things indicate that the text must be from the beginning of the string to the start of the string, no capacity for space. And the plus means one or many of these here. It's kind of like done, well, kind of done in postfix really, isn't it? That plus indicates one or many of them. Okay, I'm not going to type that in. I think I've pretty much said it. Okay, we'll have a look at the marking scheme though. There you go. The function will check whether the string matches this criteria. So therefore, the item string is valid. Is a valid integer and can be cast to the main integer for processing. Probably should have said that. Let's see what the question says. May have missed a mark if I hadn't said that. Explain the purpose of the regular expression. Oh yeah, it did ask what is the purpose of it. Well, we're checking the number is a valid integer before passing it on to the next function, whatever that is. I'm not going to look at it. You should put that in the answer though. What would happen if the regular expression was changed to that by removing the plus? Well, I've said that the plus means one or many of those digits 0 to 9. By putting the plus, removing the plus, it will only accept one digit. If somebody tries to put 2 digits in at all, it will fail. Okay, so that's that one. We can sort of see that on the marking scheme if you're a reader on this. Without the plus character, the function will only match against a single digit. Okay, so 13 would be invalid. Right, unluckily. Okay, this question is about the evaluate RPN function. It evaluates the expression in reverse Polish notation. Briefly describe how reverse Polish notation works and how it can be evaluated using a stack. Well, if you're not quite sure about this, I don't intend to explain it in this video, actually. Simply put, well, I will briefly explain it, okay? So when you're going through a numbered list, like 1 space 2 space plus, that is basically 1 plus 2. It puts 1 onto a stack, it then puts 2 on the stack. Oh, we've met an operator. We don't put the operator on the stack. Usually, okay, and what you do is you pop the last 2 numbers off on the stack, apply the operator to them, so that's 1 plus 2, that equals 3. You put the 3 back on the stack, so at that point there's only a 3 on the stack, and basically that's your answer, okay? And you would do that no matter how long the reverse Polish notation went on for. Probably an idea, if you're not quite sure of that, have a look at Mr. Brown or Craig and Dave just about how a stack is used. There may very well be a question on that, given that it is part of the skeleton code in section C. Okay, what would happen if an invalid operation, e.g. division by 0, is attempted in this function? So let's go and find that evaluate RPN. Okay, evaluate, oh, drat. Okay, so there it is. So if there was a divide by 0 that somehow came about, you're not allowed zeros in the numbers allowed list. And I think, I'm not entirely positive about this, but briefly thinking about it, if you're not allowed a 0 in the numbers allowed list, even if you were to do something really quirky, you still wouldn't get a 0 because of the rules of bid maths in it. However, if this divide by 0 was called, if you're not quite sure how this works, it's in my first video. Okay, but it basically goes through the expression, finds the operators, and applies the first operator with the second operator, pushing and popping them onto a stack. I guess I think that's clearer in Python, which actually has pop and push, and that we're basically removing at on with our little stack. Okay, as opposed to popping. Remove at is the same thing. So if that number 2, if you had 5 there and 0 there, this program would fail. It would crash out and do something programs are never supposed to do, crash with some weird and wonderful programming runtime error, divide by 0 or whatever, that an end user wouldn't understand. Basically, you would normally trap these errors using the try catch command in C#. So you would say something like that the divide by 0 isn't in any way trapped by either a try catch or even a simple if statement there to check that number 2 isn't a 0, and therefore the program will crash. So I'm not going to type that out. We will have a look. Okay, so the function will crash. No specific error handling is present for such cases. Okay. Just going back to the previous question, the big advantage of reverse Polish notation, by the way, is you don't have to do you don't have to have parentheses in them when you don't have them in, and so it's a lot easier for computers to evaluate using reverse Polish notation or postfix. And there's my little explanation. Probably a lot simpler than I said it, but there you go. Okay, I think we'll probably, should we go up to number 9 on this video, not make it too long? Okay, you probably get the idea of the kind of questions. Nobody can really predict what these questions are going to be this year, but it will be something around the variables. If you understand the program and what each of the functions do, and you answer them logically like we're doing now, you should be able to harvest most of the marks for section C. They're not particular. Well, if the zigzag is anything to go by, they're not particularly hard, I don't think, if you know the code. So in training mode, numbers allowed is populated with a fixed list. Okay. In random mode, the list is filled by generating random numbers between 1 and max number inclusive until it has 5. Oh gosh, I'm reading the mark scheme. Okay, so examine the function fill numbers. It works differently in training and random game modes. Okay, so we'll have a quick look at fill numbers. I think I need to go to the beginning of the code. I expected that to work. It usually does. Okay, so fill numbers, it operates differently in training mode to random mode. In training mode, this part of the code here, these numbers that are hard coded into the program are replaced in the list. If it's not a training game, then the numbers allowed is random numbers are generated until 5 random numbers are added to the numbers allowed list. Again, a bit of iteration there. Okay, so I think we've read that answer out. So in training mode, the numbers allowed is populated with a fixed list of numbers which are hard coded into the program. In random mode, yeah, okay. What I didn't say was between 1 and the max number being 10 by default until it has 5 elements. So you can't see the random number in here, but if I was to search for get number, that basically simply calls the random. get number. There you go. Random number generator between 0 and max number. So basically between 0 and 9. We add 1 to it, so it basically makes it between 1 and 10, the number that you get. Okay, so that's that. Next question. A stack is used to ensure operators are applied in the correct order based on their precedence. Higher precedence operators are applied before lower precedence ones. And a stack helps to man. Oh, I'm reading the answer again. Okay. Let's go to the question. It certainly makes answering these questions easier if you've read the answer first. Explain the benefit of a stack. Explain why the benefit of a stack is used to manage operators in this function here. Okay, so a stack is used in that okay, and here it is. So here is, if you watch the first video, it's held in the dictionary. Each of the operators, you could add an extra operator on there if you want for, powers or something like that. Okay, you've got a dictionary, and that is the precedence there too. And then these have got a higher precedence because you do a multiplication before you do a add or subtract. Same with division. So the stack effectively is this list of operators. Again, probably clearer in the Python version of the program, but we're adding to the list of operators. So the operators, by the way, are these plus, minus, asterisk, and divide. The operands are the numbers. So 2 plus 3 has 2 operands, and the plus is the operator. So make sure you understand that. But the purpose of this stack here of operators, which is held in the list, is that we can shuffle around within this little bit of code here the order of precedence of the of these. I haven't dry run this little bit of code, to my shame, but I can clearly see kind of what it does, and how it uses this dictionary and the precedence order here. Okay, and this particular command here of being the operator and the previous operator are equal, and the precedence is equal to the current operator. Okay, so you can sort of see what that does. You might be asked to sort of trace this, I don't know, or describe how it does it in the code in the exam tomorrow. But there you go, that's what it does. It helps shuffle around the order of the stack. We've read through the answer to that. Okay, the stack is used to ensure that the operators are applied in the correct order based on their precedence. Higher precedence operators are applied before lower precedence ones. The stack helps manage this ordering. Okay. Next, how does the function handle the operators of equal precedence? So equal precedence. Yeah. Well, that's greater than, that's equal to. So it does this here, okay, which is basically looks like it's shuffling it around or moving one to the other. I'm just going to refer to the mark scheme. I don't want to waste too much of your time on this. Okay, so after the while loop is completed, a matching precedence operator will be popped off the top of the stack and put into the output prior to the new operator being pushed back onto the stack. Okay, so that's kind of what happens there. Okay, so get target. Okay, this question is about the create targets. Okay, what is the role of get target function within the create targets? Don't really need to look at the code for that, but we will actually. So create targets. We do this get target here. Okay, and the get target, we'll look at what that does. Get target simply generates a random target. Okay, so it populates, it returns a random number between 1 and 10. We'll just check that. The role generates a random number between the 1 and max target, which is typically 10, to be added to the targets list. Okay, that is the role of that. Okay. Explain how the targets list is initialized at the start of the game. Okay, how it is initialized differently. So if we look at the start of the game, let's whiz up here. Okay, so if it's a training game, we get these hard-coded values passed into it. Okay, if it's a random game, it populates the targets with 20 random targets, which is from this function here, create targets. Simple as that. And we'll just refer to the marking scheme. Okay, in the training game, the targets list is initialized as a list of literal integers, okay, which we've got hard-coded into the program. In the random game, the create targets function is used to build a list containing 5 ones. I should have said that. Okay, 5 minus 1. So if we look at the create, it's because again I'm rushing. Let's have a look at the create targets function. Here we go. So first of all, we add 5 minus 1s on there for the spaces, and then 1 to the size of targets minus 5. So if the size of targets is 20, then we do 5 blank spaces or minus 1s, followed by 15 random targets added to it. So if you say that, you'll be fine. It's 2 marks, I think, and you've got made 2 points there. Okay, this next question I'm not necessarily going to go through. Actually, maybe I will, because to sort of come together. This question is about the play game subroutine. Below is a hierarchy chart of the play game. Name the 6 user-defined subroutines labeled A to F. So play game, if we go to play game, oh yeah, here we go. And you can see the subroutines that are check if user input is valid. Okay. What else is there in play game? Check if numbers are allowed. Check if the input evaluation is a target. Okay, let's have a look at the marking scheme there. So there we go. Zoom in on that. Okay. There they are. Check user input is valid. Check if user evaluation is a target. Don't forget your open and close brackets. Fill numbers, which was there. Remove numbers used. And then you can see that in check numbers used are allowed. Then it does a check valid number. So you're basically just going through them. And then you're asked to describe what each one of them does. So we'll just quickly do this and we'll finish the video, okay? Check if user input is valid, validates the expression using a regular expression. So, I mean, there's 6 marks here if it's something like that. We'll look at the code so we can describe it. So you're asked to describe each one. How annoying. Check if user input is valid. Is that the one? No, it's not. Here we go. So you're asked to describe what check user input if user input valid is valid. So it just uses a regular expression to match to produce a valid equation. Okay, so it validates the expression using a regular expression string and will return true. Okay, convert to RPN. Well, as it says, really converts the expression to a list of RPN symbol strings. Okay, it is a list that it throws back, so you need to say that. Check numbers used are all in the numbers allowed. Okay, so this ensures, well, we'll have a look at it. Okay, again, hopefully I can just pop that into here. No, it doesn't like it. It does not like me doing that. I think it must put a space in it. Okay. Yeah, it has, you know. Okay, that's what it is. Okay, so what does this one do? It checks. It basically creates a temporary list, and then it checks to see if the user input, each number is allowed to be used. So it does this by populating the first of all the temp numbers with the user with the numbers allowed list. So you've got an identical list in temp. Whenever a matching number is found in the user input, just to make sure we don't use it twice, we remove it from the from this list when it reaches a valid match, a valid evaluation. Okay, we remove it. So it ensures that all the numbers using the expression are available in the number as allowed list. So they are, so it will return true. Okay, I'm just going to quickly check over the question here. Right, yeah, so the question is, describe the purpose of functionality. A, from as part of your description, you can choose. Oh, right, you can assume that the player enters a valid expression and only available numbers, and it will correctly hit one of the targets. So you're describing it. I hadn't read the question before the marking scheme, which is probably the wrong way of going about it. But you're assuming that it's a valid expression, that the numbers allowed have been used and it's correctly hit, hence the way it's describing it. Okay, they are, so it will be true. Okay, check if user input evaluation is a target. Okay, so we'll have a look at that function. Again, it's put in some spaces. I'm going to remove that in that tiny print. Okay, so if this is hit a target, then it increases the score by 2 for every target hit, and it will return a true. Okay, because it's set to true there, and it will return a true. So okay, evaluates the expression using that function, compares it to the targets, adjusts the score by 2, Also changes the target to a -1 in order to be flagged as solved. It is, so this function will return a true and a new score to the player. Okay, yeah, the score has been updated. So that's that one. Where are we up to? Okay, remove numbers used. So we know that that removes the numbers used from the list of available numbers and overwrites the numbers allowed list variable. Okay, we'll just check that one out. Have a quick look. Okay. So here we're checking. We convert it to UPRN. Sorry, not UPRN. We convert it to RPN, reverse Polish notation. We iterate through the values in there. We check to see if the number is within range. If it is, which it is, because we're assuming it's all correct, the numbers and it's contained into the numbers allowed, then we remove it. Okay, removes the numbers used in the expression from the available numbers and numbers. Yeah, it's a simpler one. It's only a 1-mark question. Fill numbers. Okay, so again, you've got 2 options on fill numbers. So we'll have a look at fill numbers. Okay, so if it's a training game, we return the hard coded values of 2, 3, 2, 8, 5, 2, 1, 2. Otherwise, we populate the numbers allowed list, which is returned with random numbers between 1 and the maximum number up to 5 values. Okay, so let's double check. Refills the available number with a fresh copy of the training game numbers. Okay, or random numbers between 1 and the max number 10 default. It also overwrites the numbers allowed list variable. Okay, for that you get 1 mark for each subroutine call and associated description. You might get more in an actual exam, I don't know. There are a few more questions. I feel like I've been talking for a little while. It feels like a natural place at 10 to end the video. I'll slowly scroll through this list here if you want to have a go at them. Okay, you can pause the video and have a look at them, and I'll just show you the marking scheme for them. Sorry, that is the marking scheme. Aha! I'll quickly show you the questions. Okay, I'll just slowly scroll through them. You can pause them like that, and then you can have a go at them if you've not got this document, which I can't send out. It is the night before, and it's good advertisement for Zigzag, actually. Okay, there is one there about the regular expression. Okay, how does it make use of the meta character plus? Well, that's kind of a repeat, isn't it? But anyway, we'll go through this to the end. Oh, there's 19 questions. So I'll just go through from 11 to 19, and you can pause it if you wish. Okay, that pretty much concludes this video series on Target Clear. I hope you've enjoyed it. I hope it's helped somebody from a C# perspective. It wasn't there to replace the absolutely fantastic, phenomenal videos that have been produced by Mr. Barrard in Python, but not everybody programs in Python. Quite a few of you will be doing it in C# or Java. It may help you, some of you who are doing Java as well. So I hope I've helped some of you to take some of the hard work out of going through this code, and all the best for your exams, guys and girls, tomorrow. Okay, and that concludes this video series. Okay, God bless. Bye.